Integers are a fundamental concept in mathematics and possess several properties that define their behavior. Here are some key properties of integers. Closure under addition and subtraction. If you add or subtract any two integers, the result will always be an integer. For example, adding 2 and 5 gives 7, which is also an integer. Closure under multiplication. If you multiply any two integers, the result will always be an integer. For example, multiplying 3 and 4 gives 12, which is also an integer. Associativity of addition and multiplication. The order in which you perform addition or multiplication of 3 or more integers does not affect the final result. For example, 2 plus 3 plus 4 is equal to 2 plus 3 plus 4. Commutativity of addition and multiplication. The order in which you add or multiply two integers does not affect the final result. For example, 2 plus 3 is equal to 3 plus 2. Existence of additive and multiplicative identities. The integer 0 serves as the additive identity, meaning that adding 0 to any integer leaves it unchanged. The integer 1 serves as the multiplicative identity, meaning that multiplying any integer by 1 leaves it unchanged. Existence of additive inverses. For every integer a, there exists an integer a such that a plus a equals 0. In other words, you can always find the opposite of any integer by adding its additive inverse. Distributive property. Multiplication distributes over addition. For any integers a, b, and c, a times a plus c is equal to a times b plus a times c. Transitivity of inequalities. If a greater than b and b greater than c, then a greater than c. Similarly, if a. This property allows for comparisons and ordering of integers. Closure under exponentiation. If an integer is raised to a positive integer exponent, the result is an integer. For example, 2 raised to the power of 3 is 8, which is an integer. These properties play a crucial role in various branches of mathematics, such as algebra, number theory, and calculus.